The ConOps, the concept of operations, developed within the ASSURED-UAM project, is aimed to demonstrate how the traffic management for the initial UAM urban air mobility operations could be delivered safely with existing ATM capabilities and scaled over time with implementation of dedicated UTM unmanned traffic management services in the next future. The first UAM devoted air taxis in service and only on demand will be likely a reality not before 2025. Today, there is a strong interest in this new urban transport system, also by airlines and by airport management companies, because it could represent a new line for their businesses. The development of vertical takeoff and landing aircraft is at an advanced stage. However, vertiports are needed, as well as the infrastructures and of course the management technologies, along with the regulations that are still to be written for the most part. In the first phase of the UAM materialization, the operations will be conducted with a human pilot on board the vehicle, before passing, over time, to a full automation of the flight. Since these piloted operations are the first step and are mainly aimed to gather more information for larger scale or high-risk operations, mitigations can be applied to allow the flights to be operated under the specific category. For the immediate scenario, 2030, it is expected that the initial drone transport applications, active since 2025, will provide sufficient experiences enabling launching of more complex types of operations. Unmanned transport of passengers will not be available yet. However, it is predicted that first VTOL aircraft will complete certification process and be allowed to operate according to regulations which are applicable for manned aviation, but not as regular operations, rather for demonstration of future possibilities. Therefore, use cases allocated to 2030 time horizon are exclusively addressing cargo transport. In particular, the cargo drone operations are integrated into supply chain management. All functionalities are available, e.g., the shipment tracking indicating the real drone position. Cargo operators' capacities increase is expected thanks to sustainability optimization, e.g., thanks to carbon footprint reduction. For passenger transport, as anticipated, the unmanned passenger transport will not be available in Europe. Only manned public passengers operations over densely populated areas, if available, will be partially integrated locally with limited modes on limited area. For the final scenario, 2035, it is expected that unmanned transport of goods will achieve the maturity level allowing for more stable, however still increasing, market share. This is also the earliest considered perspective the unmanned passenger operations will be allowed from or to urban areas in Europe. However, still in limited and not commercial manner as initial demonstration of feasibility. Since the use cases for this time horizon are expected to involve the transport of people, the operations automatically fall within the certified category. About goods delivery, fully autonomous and paperless goods supply chain, automated warehousing and goods loading unloading will be available. Integration and digitalization of transport in densely populated metropolitan area require cargo drones to operate solely between nodes, which are dedicated, secured ground infrastructures. About passengers transport, autonomous passengers air transport is expected to be in testing phase in Europe, therefore not yet fully integrated. Manned public passengers operations over densely populated areas, if available, will be fully integrated locally. In terms of use cases, ASSURED-UAM considered different private and public services. About private services, the direct last mile delivery is expected to be operational in 2025. In terms of commercially driven simple operation of local delivery of small and light parcels from defined distribution point to final destinations. The advanced last mile delivery is expected in 2030. In terms of more complex logistics, with the use of heavier carriers able to deliver more than one parcel during the same mission. The automatic personal aerial transportation finally is foreseen in 2035 in terms of initial and demonstrative, not yet mature operations. Regarding public services, the point-to-point public services are expected to be operational in 2025, implementing high-priority public service-related tasks, realized in the framework of private-public partnership. In 2030, then, the point-to-everywhere public services are expected, allowing more complex and more demanding operations compared to point-to-point services. Direct medical transport of people is finally expected in 2035, as testing operation of unmanned vertical transport of passengers' patients between hospitals. In order for UAM to be integrated into the urban framework, several actions will be needed to adapt cities and allow them to accommodate this new mode of transport. The operational barriers to the deployment of UAM are mainly of infrastructural and technological nature. Regarding the infrastructural aspect, the first barrier addresses the ground infrastructures necessary for passengers embarking and disembarking, as well as for departure and landing operations. For instance, the first vertiport prototype, called Voloport, was built in October 2019 in Singapore by the UK Skyports company in collaboration with the German company Volocopter, a pioneer in the research and development of enabling technologies for the development of UAM. With respect to investment and regulations for infrastructures integration, the feasibility and cost-effectiveness of integration of UAM infrastructures into existing urban environment, buildings and networks could be a critical issue, emphasizing the relevance of point-to-point UAM application and integration with other modes for UAM development. Technological limits such as UAM vehicle characteristics, propulsion capacities, covered distance and so on, use-based services, city digitalization, and ICT, information and communication technology problems are fundamental. Starting from the UAM vehicles analysis, it is important to define the basic parameters of the vehicles for UAM operations. Dividing and subcategorizing them enables a deeper understanding of issues and obstacles for the use of drones in the urban transportation applications. Huge efforts should focus primarily on the full automation concept. Indeed, as for the 4D contract, indicating a precise and negotiated scheduling of flights along with rigorous tracking of flight paths and times at each waypoint and inside assigned corridors. The technology involved is relatively advanced. In fact, even though the underlying organizational strategy requires further work, a number of technological building blocks are already available. Thus, implementing the concept is only a question of financial resources, political will, and social acceptability. Door-to-door mobility paradigm is nowadays considered for mobility in urban and peri-urban areas, as well as at overall European regional transport level. As also analysed in the X-Team D2D door-to-door project, this paradigm offers new passenger-oriented perspectives, such as mobility as a service, an innovative approach to mobility management, integrating into a single framework all modes of transport, both private and public, which are available in a city, offering the user the possibility of planning, reserving, and paying for the intended trip by using only one personalized application and ticket. These new paradigms obviously need the sharing of information between the various transport systems. For example, the weather information exchange models and schema is a system designed to enable the platform-independent, harmonized, and interoperable meteorological information exchange covering all the needs of the air transport industry. The specifications of such a system support the data-centric environment, supporting information collection, dissemination, and transformation throughout the data chain. This is only one example of the multiple data and systems that need to be integrated to allow the targeted mobility paradigm shift. Integrating the different transport systems will enable effective disruptions management, as different modes of transport offer alternatives for conducting the initial planned journey. These alternatives increase the flexibility needed for robust disruptions management. UAM deployment has one of its main motivations in its potential to circumvent congestion on the ground due to surface transportation capacity saturation. In this way, UAM represents a new possible leg of an integrated seamless journey, allowing multimodal possibilities, as considered in the X-Team D2D project which collaborated with ASSURED-UAM. Effective disruptions management will be enabled by evaluating and sharing impacts of disruptions across different mobility means. The shared repositories coming from different mobility means will enable information sharing, allowing data fusion, mining, and analysis. This will positively impact mobility performance metrics, enabling increased levels of D2D mobility integration. The end users will exploit this information for real-time decision-making, switching between alternative available mobility modes to complete their journey. Thus, the system will be resilient to disruptions, offering several modes of transport alternatives to conduct the integrated unique D2D trip. In UAM, dedicated air, also named vertical, traffic management is obviously needed to coordinate flight operations in the urban airspace. This encompasses not only technological aspects, but also regulatory ones, as well as policy governance. U-Space ecosystem will gradually provide the whole set of services needed to allow integration and coexistence of both general aviation and UAM operations with the proper level of safety, typical of aeronautical operations. Thus, updates of national and international aviation rules and standards are needed to enable the UAM vehicles' safe flight and to transport their safe integration with existing transportation modes. The development of UAM vehicles required the implementation of new engineering and technology solutions that are proven to be safe for passengers on board and for the city over which the vehicles are flying. As important as the technological innovation is the creation of regulations and standards to provide public confidence in these new urban and peri-urban transport solutions to be adopted in daily journeys. Scenario is a tool for imagining future. In transport systems theory, it is typically applied for designing or redesigning and planning. Scenarios are generated by different assumptions on exogenous variables or represent subsequent system states after changes application. We assumed the present system uses the 2021 transport infrastructure in considered cities and modes available today, as well as these gaining popularity. As a project system, we assumed the services as defined in the use cases on top of the present system. We distributed forecast scenarios along time horizons and EU transport strategies. Our model is most probable. We chose central values of the forecasted exogenous variables and represents a mixed method. A qualitative analysis of future and a quantitative spatio-temporal static representation. We selected probable itineraries addressing the use cases and calculated their indicators: costs, time of travel, and emissions. Finally, we identified how many UAM operations are needed for UAM cost competitiveness. Our scenarios are based on the following exogenous variables: inflation, wages, currency exchange rates, oil prices, electricity prices, its generation emissions and sustainability expectations. There are risks related to inflation and controversies in Poland over EU funds and policies. Although inflation in Italy and Portugal is also expected to increase due to energy prices, the effect is not as strong as in Poland, and it will be offset by strengthening of the euro against the US dollar and other currencies. This will not be the case of Poland, as it is not yet a part of the Eurozone. In the result, wages increase will be much more offset in Poland by inflationary growth of costs than in other considered countries. Mobility efficiency has been traditionally driven by oil and gas prices. Oil will continue to play an important but diminishing role in certain niches of transport like long-range delivery or military logistics and vehicles. The reference scenario of Brent oil prices reported by the US Energy Information Administration typically assumes more or less intensive price increase. On the other hand, other energy sources' role, in particular available as electricity or green hydrogen, grows substantially. Renewables, bioenergy, geothermal, hydropower, ocean, solar, wind, as signalized by International Renewable Energy Agency, will be a significant source of energy by the year of 2030, if not before. Energy transition is critical to our habitat survival on the planet. but it is not without extra costs on top of day-to-day operation upkeep. Each pan-European scenario of electricity generation reform, be it single or multi-objective, perceives unit costs of megawatt hours to be increasing up until the late 2030s in exchange for substantial emissions reduction. Even if we do nothing, the costs will gradually increase anyway, but the risks of climate-related chronic and acute temperature, wind, water and solid mass-related hazards will inevitably emerge as defined by the EU taxonomy. The EU taxonomy for sustainable activities follows do no significant harm principle. The renewable sources of energy, including wind, sun and hydro, together with fossil, gas and nuclear reaction, according to the taxonomy, are to play the main decarbonisation role in mobility. Fair approach to compare modes of transport requires considering emissions of the whole life cycle, including beyond direct operating emissions of vehicle, which means investigating other aspects including local energy mix represented by global warming potential of electricity generation by country. Italy is converging towards net zero emission, having a substantial component of wind and sun as a source. The status in Portugal is quite uncertain, yet it is much better than in Poland, which mainly uses coal and lignite, and, as it seems, it will continue to do so. Urban logistics is under great transformation and has many challenges ahead. Private citizens, companies and public institutions could benefit in the future from UAM cargo services according to patterns shaped by future business models, organizational culture for business-to-business case, citizens' lifestyle and social changes for what concerns the home or close-to-home delivery to private citizens. UAM passengers will correspond to an enlarged group of current air taxi business passengers. They could be considered as a sort of early adopters of this new transport mean, and they will be either business or private travellers, able and or willing to bear higher costs per mile for different reasons. Contemporary cities are experiencing a dynamic transformation towards sustainable urban systems. Local authorities implement incentives to encourage modal shift to active travel, cycling and walking, and public transport, or discourage travel at all. In this sense, global urban leaders begin to implement a 15-minute city rule ensuring access to healthcare, food, schools, work, recreation, leisure spaces within 15 minutes from homes. On the other hand, technology very quickly outpaces regulations, and it is possible that future metropolis will have to deal with the emergent concept of air mobility. Companies, as Wing or Amazon, already obtained the FAA certification for the American market and offer small goods delivery services there. In Europe, U-Space ecosystem will gradually provide the whole set of services needed to allow integration and coexistence of both general aviation and UAM operations with proper level of safety. The near-term step is enabling a set of services foreseen in the U2 level, i.e., planning a flight mission, its approval, tracking of drone movements and interaction with air traffic control. Only full services of U-Space will enable safe passenger flights. The indicators comparison between the legacy modes and UAM proves attractiveness of UAM in certain niches. UAM has a potential to be cost competitive with lower or comparable time of travel in comparison to the most possible other modes in urban delivery business and public emergency deliveries. Use case 1, use case 2, use case 4. Advanced logistics, use case 3, medical transport of people, use case 5, and passenger transport, use case 6, seem to be not cost competitive except in case of very high value of time and vicinity of the landing pads. With fossil fuels as a source of energy, only helicopter generates more emissions than UAM. Comparability of exposure, i.e. common denominator, is critical in emissions calculation. If relax this rule, and we assume better load factor for UAM, its emissions will be close to electric bike, but still not as good as those of electric car, with a humble load factor of 0.38, but a large trunk. The obvious is, one needs less energy to roll than to float.